All right, yesterday we did like addition and subtraction. We learned, the basics about imaginary numbers and complex numbers. We know that I is the square root of -1. We know all that good stuff, and we did a lot of addition, didn't we? All right, so we are now going to do some multiplication, and we're going to do some division as well. We did a little bit of division yesterday, but not quite the same division that we're going to do today. So let's do a little bit of multiplication. All right, let's make one up here. For multiplication, what if you had something like this? 3 times 2 plus 5i. This is real baby stuff, okay? Even though this is an I, this is not just a variable, though, is it? It's a square root of -1. But I just want to show you that you can still multiply just like you would if it was a variable. If this was an x or something, you should be able to do that pretty easy. So this is a real number being multiplied by a complex number is what it is, all right? So, yes, sir? Can't see it? You don't like that color? I've used that color a lot before. Nobody said anything about it.
I love that color.
How's that? Is it any better?
I like the blue better.
Well, we got to be able to see it, though. All right, so here we go. Oh, you know what? After I watched that YouTube video yesterday, you catch yourself saying things over that you don't think about when you're saying it. I have a verbal crutch. Do you know what my verbal crutch is? So now that I'll say it to you, every time I say it, you're going to laugh and think about what I say. But I say all right. I always ask all right. All right? We're going to do this. All right? All right? All right? I probably said it 100 times in that video. And it bugged me. I was like, what? So I got it. I have to think about my verbal crutch right there. And like, everybody says that. I even say it. Even adults today now say like all the time. Back when I was a kid, nobody said, hey, like this, like this, like this. Everybody says it now.
To some of the recordings from NOPSP too.
And you hear like all the time? Yeah.
Yeah, I keep some of it.
Almost said it again. All right, let's do this. It's kind of like my thing.
I'll get rid of like 2/3 of it.
What should I say it? Okay, I know. It seems like I have to say something before I say it. It's weird when you think about all these things. So, that's a good one. So, let's look at this. See, now I'm going to be aware of it. It's going to bug me. I shouldn't have even said anything. 3 times 2. Let's distribute. 3 times 2, that's 6, plus 3 times 5i is just 15i. It's just as easy as that. Got it? Pretty easy. What if you had something like this? Let's make up another one. Let's say 5i plus 2 minus 7i. This is a little bit different, isn't it? So let's figure this one out. Distribute. We've got 10i, good. And then it's minus. Now watch this. You could do a little bit of this in your head, but let me write the step down first. Okay, eventually you should be able to do this in your head, but let's just write down the step. 5 times 7 is 35. Okay. I times I is I squared. Now, you may have been able to look at this and say, I times I is I squared is -1, -1 times -35 is plus 35. You could have done that, and that would be fine. I would be fine if you did that. I'm just writing down the steps so you see what we're doing, so you don't get too lost. So, look at this. 35 times I squared is -1. I'm writing down every step. You don't have to write down every one of these steps. I'm just doing that so you can see the progression of where I got this. So this is minus again. 35 times -1 is -35. Again, I'm going a little overboard on my steps, but I want to show you everything I'm doing. So this is 10i minus a negative is plus 35. Do we write it like that, and do we circle it? Why not? Put the real first. Very good. We call that standard form. Very good. We call that standard form, so put the real first. So even though all your arithmetic and your numbers are right, you really want to put it in the correct order. So put it in standard form. So 35 plus 10i. Now, if the problem says to put it in standard form, and this worksheet does, it says for the almost all of these, it says put it in standard form. So if you wrote it like this, and it said put it in standard form, guess what I would have to do to that problem?
Darn it.
I would have to mark it wrong if it was a quiz or a test. And I would hate to do that for something silly like that. But if it says put it in standard form and you don't, then you didn't do what the question asked, did you? So you got to make sure it's in standard form. That would be your answer right there. We good? take that as a yes. I take silence as a yes, so we'll keep going if you don't say anything otherwise. Now, let's do this. See, now, there was my little break. So I got so and I got now I got to use instead of, all right. Let's do this one. If you could do the problem that we just finished doing, this shouldn't be a problem at all either, or it shouldn't be a difficulty for you. It is a problem. It's a math problem, but it shouldn't be a tough problem. What are we doing here? We mentioned this earlier when we were going over the homeworks. It says FOIL. This is FOIL this time. Why is it FOIL this time and it wasn't when we went over that homework? Because there's no plus or minus in between. It's being multiplied. There's no sign in between those parentheses. It's being multiplied. So we distribute. Right? It's distributive property or FOIL method, however you want to look at it. So let's do that. Let's do the FOIL method. First, outside, inside, last. So let's do the first. 2 times -1 is -2. That's the first. Then the outside is 2 times positive 3i, and that's a 6i plus 6i. This is no different than what we've done before until the very end when we deal with that I. Because if this was an x, you would have done this problem exactly the same, wouldn't you? At least started off exactly the same. Let's do the inside. This is going to be minus 4i. And let's do the last. That's going to be a plus 12. I times I is I squared. Now again, you could have looked at this and done this in your head. You could have said, oh, I squared is -1 times 12 is -12. But I wrote the step down because I wanted you to see in your notes when you look back at it exactly what that was. All right, there I go again. Plus 2i. What's this going to be? We can go. We don't have to put the -1 here. We can do this in our head a little bit right here. So what's 12 times I squared? It's -12, right? But now I have to multiply it by this -2 over here. So let's do that. -2 minus 12 is -14, and then plus 2i. Is it in standard form? Yes, it is. And that's why I always do the real numbers first, so it's already in standard form. So really, is there anything more difficult about this than if it was an x? Not much. The only thing that's different is just understanding that I squared is -1. If you understand that I squared is -1, this is really no different than what we've done before with regular FOIL method. Agreed? Yeah. Let's do this one. Change colors. Alright, here's one. Alright, here I go again. So you guys don't even notice I say that, do you? 6 plus 4. Look at this one. What does that kind of look like? Difference of two squares, right? Because they're both exactly the same, except one's minus and one's plus. So remember, you could go through the whole entire FOIL method if you wanted to, but it's a little bit of a shortcut, recognizing it's a difference of two squares, isn't it? All we got to do is multiply which ones? The first and the last. The outside and inside is going to add up to 0. I don't have to worry about doing that. So let's just do the first and the last. So we multiply the first, it's 36. Multiply the last, it's -4 times 4, 16. And then I times I is I squared. So far, that was nothing new. This is the only new part. It's just understanding that I squared is the same as what? -1. So this is going to be 36 plus 16. That's right. Because this is going to be a -1 times 16 is -16. Minus a negative is plus.
20.
You getting that? 20? What? No, it's plus. It's plus. Right? It's not minus. Because this is a minus.
Plus.
Okay, so that's 52, right? Did I do the math right?
So the I goes.
Yeah, the I goes away on this one, doesn't it? On a difference of two squares. And that's a good observation because it's something that we're going to do in here in just a minute. All right, that's a good observation. What happened to the I? It went away. When does it go away? It didn't go away here, did it? When did it go away? Is when I'm multiplying. And we have another word for this as well, don't we? Remember this? If they're both, like if this is a negative, and what did I do? I multiplied by the same thing, I just changed the sign of it. Do you remember what we called that? It starts with a C. We've done this before. A conjugate. Isn't this the conjugate of this? They're conjugates of each other, right? So look what happened. When you multiply a complex number by its conjugate, what happened to the I? Went away, didn't it? Okay? Everybody see that? That's pretty important for what we're going to do here in a second. In fact, let's just go right to it then. Is that all right? We'll go this light green. So let's do this. Let me get it. Let's do this one right here. 1 minus 3i. I tell you what. Let's do this instead. I'll get to this in a second. All right. All right. 2i. What if I had this and I asked you to simplify it? Simplify. All these say simplify, I believe. Or it might say divide, but whatever. Why is that not simplified? What's up with that? It looks simplified to me. Doesn't look like anything cancels out. 2 doesn't go into 3, right? I can't cancel out the i's like this because this is part of a subtraction problem. We've talked about that 100 times before, haven't we? Why is this not simplified? We have an I on the bottom. So big deal. I never said you couldn't have an I on the bottom, did I? Yeah, and you have it on top as well. But you're getting somewhere. I'm just playing like devil's advocate right here. Why can't you have an I on the bottom? Because it's not just negative, it's a what?
It's technically a square root.
It's technically a square root, exactly right. So remember what I is. It's not just a variable, is it? It's a square root. It's a square root of a negative 1. So can I have an I on the bottom then? No, I can't, because we're not allowed to have square roots on the bottom, okay? No, I'm not going to divide. Now watch, the 2's fine. I'm perfectly okay with the 2 right there. What don't I like?
The I.
The I. Don't like the I. The 2's going to stay there. I'm not going to mess with the 2. But I got to get rid of the I. So do you remember how we did that? Let's go back in time a little bit. Remember we had something like this? What did I do to get rid of that square root of 2? I just multiplied it by itself. Now, there's no conjugate here because there's nothing being added or subtracted, okay? All I did was just multiply it by itself, because when I take a square root and I multiply it by itself, it gets rid of that square root. But I had to do that to the top as well, didn't I? Remember that? Okay. This is the same thing, though, isn't it? But I'm trying to get rid of the I. I'm okay with the 2. The 2's going to stay there. I'm not going to get rid of the 2. It's the I that I want to get rid of. So the I is a square root of negative 1. So how do I get rid of it? Multiply it by an I. Because what's I times I? It's I squared, which is negative 1. And that'll get rid of the I, won't it? On the bottom, anyway. And so if I do that to the bottom, I have to do it to the top. Why do I have to do it to the top as well? Because really, I'm multiplying by 1. Right? Because anything over itself is 1. Got it? So let's see what happens. Let's go back to green. So let's do the bottom first. You know how I always like to do the bottom first? It's 2 times I times, or it's 2 times I times I. Well, we can do this in our head. What's I times I? I squared. What's I squared? Negative 1 times 2 is negative 2. So it just turns into negative 2. You okay with doing that much in your head? If you're not, if you get confused, write it all out like I did earlier. But I think you can handle that. What about the top, though? This I is being multiplied by, not just by 3i, not just by 1, but by that whole thing. So what do I have to do with that I? Distribute it through. See, it didn't originally have parentheses around it, did it? But I put them around there because I know this has to be multiplied by this whole thing. So let's do that. It's 1 times I, which is I, minus 3i times I, which is 3i squared. Now again, you might have been able to do that in your head, and that would be okay, but I just wanted to show you what's going on here. Now that is what? Negative 1. So this is really going to be I what? Plus 3 over what? Negative 2.
Switch.
But I want to put this in standard form. So let's put the real first. So 3 plus I over negative 2. Now that would be kind of acceptable. I'm not sure. I don't have the answer right in front of me. And we're running out of time for me to go search for it. But that would be okay. I'll tell you right now, just leave it like that. That's fine. Some teachers might be a little bit pickier on here, and I could kind of show you another way to simplify it, but that's okay. As far as I'm concerned, that's good. I'll just show you what it would be. It would be negative 3 over 2 minus 1 over 2i. Technically, that's probably a better way to write it. Do you see that? Because I split it up into a real part and an imaginary part. Because look, 3 over negative 2 is negative 3 halves. Agreed? And then that's a 1i, right? So it's 1 over negative 2. So minus 1 over 2i. That's kind of the best way to write it right here. But I'd be okay with this. If you wrote it like that, I'd give you credit for that. It's fine. Let's do one more. I have time to do one more. Now, remember what I said? We are going to do this thing multiplied by the conjugate. Now watch what we're going to do here. I'll just make one up. What if we had 3 over 2 plus I? I'll make it kind of easy. What if we had that? It's not simplified because you have an I on the bottom. So how do we get rid of it? Do we just multiply by I like we did in the other problem? We got to multiply by what, Destiny? 2 minus I. That's right, because look, we multiply by the conjugate. Since you're being added, since it's a sum right here, we multiplied by the conjugate to get rid of it. Everybody see that? That's very, very similar to what we did before, except what did we do before when we first taught this stuff? We had square roots here. But technically, this is a square root, isn't it? So really, it's not much different at all. So we got to do the top as well. We good with this? All right. Ask me questions if you have any. Let's do the bottom first. We're multiplying by the conjugate. So it's 4, right, minus I squared. What's I squared? Negative 1. I didn't write I squared in there. I just saw that in my head, but I put down a negative 1. Let's do the top. That's going to be 6 minus 3i. Let me finish. So 6 minus 3i on the top, and on the bottom, 4 minus negative 1, which is a 5. Again, I'd be okay if you left it like this, but there are some teachers that will make you split this up and split it up like this. 6/5, what do you think? Minus what? 3/5 I. That's probably, that way right there is probably the best way to write this answer because you've got a real and you've got an imaginary. If you wrote it like this, I'd be okay with it, all right, for right now, but just realize that you may do this stuff in college and your professor or teacher might ask you to write it like this. All right, but I'd be okay either way. Either way would be it. All right. That pretty much covers everything, I believe. Oh, well, I'll tell you what. Do this. Do 1 through 5 and 11 to 15. I ran out of time. I didn't even realize that was on there. 6 through 10 we'll do tomorrow. So 6 through 10 we'll do tomorrow. So you won't be able to do 6 through 10. It's going to take me at least 5 minutes, and the bell's going to ring any second now. So, all right, let me give you the worksheet, and then you can work on that tonight.